right, people. We should be good doing these, I hope. You just did a bunch on a practice sheet, I believe. But inverse cosine, negative root 3 over 2. Inverse cosine is in these quadrants. This is where it's positive. That's where it's negative. So we're getting rid of that. Root 3 over 2 comes from a 30, 60, 90. Okay, 1, root 3, and 2. So we need adjacent over hypotenuse, so to be root 3 over 2, which is 30. So the reference angle is 30. So our answer is going to be 150, or in radians, it's going to be 5 pi over 6. Okay. Second one, arctan, negative root 3 over 3. Arctan, whoops, is from negative 90 to 90, positive there, negative there. So it has to be in the fourth quadrant. Again, we're using a 30, 60, 90 triangle. We need opposite over adjacent to be root 3 over 3, or 1 over root 3, means the same thing. Okay, and that's going to be a reference angle of 30 again. However, we can't say that it's going to be 330. It's got to be negative 30 or negative pi over 6. Okay, inverse sine of negative 1. So the sine of what angle is negative 1? Okay, positive here, negative here. It's going to be this down here, which is going to be negative pi over 2 or negative 90 in degrees. Okay. Even though it says give your answers in radians, I'm giving them both just to make sure we understand what's going on. All right, and inverse cotan of root 3. So cotan, same as tangent, it's 1 and 4. Okay, we need a positive here. Radical 3 over 1 for adjacent over opposite. So adjacent over opposite is going to be a reference angle of 30. So our answer is going to be pi over 6 or 30 degrees. Okay. So that's inverse trig. Okay, if you ever see cosine negative 1 or arc cosine or arctan or that stuff, that's inverse trig. Hopefully you know the domain restrictions. Now we're going to start solving equations here in a second. But so now we want to look at some things with our calculator to start. So here's my calculator. Okay, it says find the cosine of 25 degrees. I'm going to make sure my mode is in degrees. So if it's not, I'm going to switch it. Second quit. I'm just going to do not parentheses, just cosine of 25. Hit enter. It tells me it's 0.9063. So the cosine of 25 is 0.9063. Awesome. All right, cosine of 335. So let's do the same thing. Cosine 335. Wow, also 0.9063. Okay, 0.9063. But now if I do inverse cosine of 0.9063, if I do second cosine of 0.9063, it's only going to give me 25 degrees. Okay, so now the question is, why didn't I get out 335 as an answer? Well, inverse cosine is only defined from here to here. Okay, so it can't give you 335 because 335 would be down there. Okay, so the calculator will only give you, for inverse sine, inverse cosine, an answer in the quadrants that it's defined in. Okay, now however, if I ask you to solve the following equation, what would we do? So if I say if cosine of 0.9063, cosine of theta equals 0.9063, and your angle is between 0 and 360, what is the value of theta? So now, we're not doing inverse cosine right now. We're not thinking about those domain restrictions. Okay, we need cosine to be positive. So we need an answer that's going to be in these two quadrants because that's where cosine is positive. Now, if we do inverse cosine of 0.9063 like we just did, okay, it spits out 25 degrees. So what that means is that 25 degrees is our reference angle that we're going to use. Okay, now 25 degrees would be our first quadrant answer, and 25 degrees as a reference angle is our fourth quadrant answer. So our answers are 25 degrees for the first quadrant, and then 360 minus 25, which is 335. Okay, here is the major difference. All right, nowhere in this problem do you see that, okay, or that. If you see these, that's when it's restricting the answers to these quadrants. Okay, when we hit the button on our calculator, which we hit inverse cosine, the calculator only gives us answers that are in those quadrants. Now, when we're solving equations, and especially this tells us what our domain restriction is, now we're going from 0 to 360, we can now get answers that aren't in these restricted quadrants. All right? And this says here, because the problem wants all answers from 0 to 360, we need to now consider all the quadrants. Okay? So now, let's look at something else. So if sine theta equals 0.4973, theta is between 0 and 360, what is the value of theta? So now, let's think. Sine is equal to a positive number. So where is sine positive? 1 and 2, so not in 3 and 4. Okay? If we do inverse sine of 0.4973, because that's what we need to do to get an angle value, so we go second sine, 0.4973, okay, we get 29.8 degrees. So our reference angle is 29.8 degrees. Okay, so that means that we have a reference angle here, 29.8. We have a reference angle in quadrant 2 that is also 29.8. So now what are the angles going to be that we get here? Well, 29.8 works as our first quadrant answer. And we need a second quadrant answer. So if we subtract 180 minus 129.8, we get 150.2 degrees. Now you can check this and go and say in your calculator, what is the sine of 152 degrees? A sine of 150.2 degrees. Okay? Hit enter, it tells us it's 0.49697, which is 0.4973, close enough. Okay? Because I rounded with our reference angle, we get a little bit, it's a little bit off, but it's close enough. Okay? Now, tangent theta equals negative 3.461, and theta is between 0 and 360. So let's think again here. Where are we going to get our answers? All right? Tangent is negative. So tangent is negative in quadrants 2 and 4. Okay? So we cannot have answers in 1 and 3. So now if I do second tangent, which is inverse tangent, of negative 3.461. So I go second tangent, negative 3.461. Okay, hit enter. It spits out negative 73.88. Now the reason why it gave us a negative answer is because inverse tangent, if you remember, inverse tangent goes from negative 90 to 90. Okay, so what we're going to do is we're going to drop this negative sign, and that's our reference angle. So the reference angle is 73.9. Okay, now we need an angle in quadrant 2 that it has a reference angle of 73.9, and also down in quadrant 4. So to get the angle in quadrant 2, we do 180 minus 73.9. So 180 minus 73.9 is going to be 106.1. And then here we do 360 minus 73.9, which is going to be 286.1 degrees. Now, if you notice, the reference angle we got, 73.9, is not an answer because our reference angle is in quadrant 1, okay, which is not where we have answers. We only have answers in quadrants 2 and 4 because that's where tangent is negative, okay? All right, cosine theta equals negative 0.7143, okay? So now let's think. Cosine being negative, we need answers in quadrants 2 and 3 because that's where cosine's negative. So let's get our reference angle. So we do second cosine. All right, let me just move this so I can see. Negative 0.7143. And it spits out 135.6. Now, 135.6 is not our reference angle, but if we think for a second, why did it spit out an angle? It's not a reference angle. Inverse cosine, which the calculator is giving us an answer for, is in quadrants 1 and 2. Okay, so we got an angle of 135.6. So our reference angle has to be 180 minus that, which is going to be 44.4 degrees. Okay, now here's what's nice about inverse cosine with that stuff. Is that we got a reference angle of 44.4, but this angle right here is 135.6, which is one of our answers because we want a second quadrant angle. So 135.6 is one of our answers, and then we have to just figure out what our third quadrant answer is. Reference angle of 44.4, 180 plus 44.4 gives us 224.4 degrees. And again, we can check our answers by just simply taking the cosine of 135.6, the cosine of 224.4, and getting what our answer is, and seeing if it matches up being this. Now, again, it's not going to be exact. It's going to be pretty close because we are rounding what our reference angles are from the calculator. Now, first thing I'm going to do, for example, before I even start, is if you look at the domain restriction now, it's switching it from degrees to radians. So my calculator, I'm going to switch right away my mode from degrees to radians. Okay. Unfortunately, if you forget to do that on a test or quiz, that is not my fault. That is your fault. Okay. So now we need sine of being 0.3732. Okay. So sine is positive. So that's in quadrants 1 and 2. Now, one thing we really haven't mentioned much yet is we need to know that this is 0, this is pi over 2, that's pi, that's 3 pi over 2, that's 2 pi. But we also need to know them as decimals. So this is 6.28. This is pi, which is 3.14. This is half pi, which is 1.57. Okay, take 3.4 and divide it by 2. And then if you add half pi and pi together, we get 4.71. That's 3 pi over 2. Okay? So now we're going to do second sine of 0.3732. So inverse sine 0.3732. Okay? And it spits out 0.382. So that is our reference angle of 0.382. .382. Okay. So now 0.382 is less than 1.57. So that works as our first quadrant angle, and we need to find a reference angle. Okay, I'm sorry, an angle in the second quadrant with a reference angle of 0.382. Well, we're going to take pi, which is 3.14, and subtract it from 0.382. Actually, I'll just make this easy and keep everything around at the 2 decimal places. So if I do 3.14 minus 0.38, okay, I'll get what my second quadrant answer is. So first one is just 0.38. That's our first quadrant answer. 3.14 minus 0.38 is going to be 2.76, I think. Yes. 2.76. So those are our 2 answers. Now let's just check to make sure our decimals match up. 0.38 is a first quadrant answer. 2.76 is a second quadrant answer, and that's where sine is positive. Okay? Hopefully these make sense. Okay? I want you to try 5, 6, 7, 8 on your own. Okay? And go from there. All right? I'll throw the answers up so you can check them. All right? In like a second, I'll just pause this, try and do it, and then I'll have the answers up here for you to see. All right? All right, people. So hopefully you guys paused this, did those last 4 questions on your own. Here are the answers to these last 4 questions. All right. 5, 6, and 7 are in radians. Okay, 5 and 6, you need your calculator. 7, you don't need a calculator, but if we say sine of theta equaling 0, think unit circle, that's when your y value is 0, so that's 0 and pi. Notice that it's not including 2 pi in our answers, so as a result, we're not going to include 2 pi because 2 pi is not in our domain restriction. And lastly, cosine theta equaling negative root 3 over 2. So the cosine of what angle is root 3 over 2? Go to a 30, 60, 90. Get your reference angle being 30. And those are your answers in quadrants 2 and 3. Okay? That's it. We're done.
Hello, everyone. So today, I'm finishing the note sheet with you that Mr. Kirkby started in a video last week. So I reposted it today on Canvas. But if you need to watch the video again that Mr. Kirkby had made on the first half of this, which is the easier type problems, go ahead and rewatch that. I'm going to take us now a step further where it's not just set up and ready for us to solve. So I have 2 examples here to start us off, relatively easy ones. So solve over the domain of 0. Theta is between 0 and 2 pi. All right, so we want to solve for theta. And in the past, you were always given a problem where it was just like sine theta equals 0.781. And you would just go right to your calculator and hit second sine, and you'd put in 0.781 and you would get an answer. So we're not ready to do that yet. We need to manipulate this equation a little bit so that we're ready to use the calculator. So the goal is to get sine theta by itself. So that's what I'm going to do here. So the first thing I'm going to do, I'm just going to do some algebra. I'm going to subtract 4 from both sides, and I get negative 3 sine theta is equal to 2. Divide both sides by negative 3, I get sine theta is equal to negative 2/3. So now we're looking at a problem like we had last week, and I am in radians. Okay, it's very clear that the teacher is looking for me to put my answer here in radians because it says theta is in between 0 and 2 pi. So I'm not going to bring the calculator up every single time just for time purposes, but I will on this one just to refresh your memory. So the first thing I'm going to do is I'm going to make sure I'm in radian mode. since my teacher is looking for answers in radians, and I am. Okay, so second quit. And now I'm going to do inverse sine, second sine, of negative 2/3. I'm actually just going to do 2/3. It's always a preference. So if I put in the positive version of it, it will always, always, always give me the reference angle, because it's going to put me in quadrant 1, right? We know our inverse sine rules, and when they're positive, every single function's in quadrant 1. So even though I'm looking here for where is sine equal to negative 2/3, I personally, now you don't have to do this, but I like to put in the positive version of it just so that I can see the reference angle. And then from there, I will get my answers in each quadrant. So this doesn't give me a solution right here. This is actually my reference angle. So let me see. I just got rid of that by accident. Let me shorten my screen here so I can see. Okay. So the reference angle is equal to we'll go out to the 100th, 0.73 radians. And now I'm looking for an answer over the domain of 0 to 2 pi. So I need my answers to be in between 0 and 2 pi, and it has to be in the quadrants where sine is negative. So I'm crossing out quadrants 1 and 2. So I need to have a reference angle of 0.73 in quadrant 3, and I need to have a reference angle of 0.73 in quadrant 4. Okay, so this would be, if this is 3.14, in quadrant 3, I'm looking for this angle. Okay, so 3.14 plus 0.73. I have my first answer. Theta is 3.87. And you guys obviously are going to have access to a calculator on these type of problems. So you could add those in your calculator if you had to. And then my answer in quadrant 4 is this guy. Okay, so it's going to be 6.28 minus 0.73, because 6.28 is right here, so we want everything but the 0.73. And I get theta is equal to 5.55 radians. Both of these are in radians. Okay, so that was a relatively easy one. I'm going to skip some as we go through, and then you'll complete those for homework. So I'm going to skip number 2 because it is very similar to number 1. So I'm going to skip that one for now, and if I have to come back to it, I will. Let me see which ones I want to do next. You know what? I actually am going to do number 2 just because it's cotangent, and I don't know if you guys if you would know what to do with your calculator for this. So let me do it with you. So I'm going to do the same exact thing. Subtract 8. So I have 2 cotangent theta is equal to negative 4. And then I get cotangent theta is equal to negative 2. So there's no button in our calculator for cotangent, right? So we have to use a little bit of common sense. So cotangent theta is equal to negative 2. There is a tangent button in the calculator, so I'm going to say if cotangent is equal to negative 2, that means tangent is equal to negative 1/2, because those are reciprocals of each other. Okay, so if cotangent is negative 2 over 1, then the tangent is negative 1/2. So this is what I'm going to put into my calculator. So once again, I'm still working in radians, and if tangent is negative, I'm going to need answers in quadrants 2 and 4. Okay, I'm basing that off of my ASTC. So I'm going to do the same exact thing I did on that last problem, and I'm going to type in the positive version of it. So second tangent of 1/2. All right, and it gives me my reference angle is 0.46 radians. Okay, so my reference angle is equal to 0.46 radians. So I need to say in quadrant 2, I need an angle that has a reference angle of 0.46 radians, and I need one in quadrant 4 as well. So that would be 3.14 minus 0.46, right? And 6.28 minus 0.46. So for me, theta is going to be equal to 2.68 radians. That's the quadrant 2 answer, and 5.82 radians. So the reason I chose to do this one with you guys was just to show you that you can always, if it's one of these reciprocal functions, you can just take the reciprocal of it, and then you're going to know what to hit in your calculator. All right, so that's why I did decide to do that one with you guys, even though I originally thought I was going to skip it. Okay, let's move on to some more difficult ones. So sometimes we might need to call upon our past Algebra 2 knowledge of solving equations with trig. Okay, so I have 4 cosine squared theta is equal to 2. So once again, I want to get the cosine theta by itself. So the first thing I'm going to do is divide both sides by 4. and I get cosine squared theta is equal to 2 over 4, which is 1/2. And I'm not actually ready yet to go with my calculator because this is being squared. So I want cosine theta by itself, so I'm going to take the square root of both sides. So I get cosine theta is equal to plus or minus 1 over root 2. The reason I did that is because the square root of 1 is 1. So I did that. That's why this top one lost the square root. I took the square root of the first one. Okay, so this would actually be a no calculator problem. I can see that I'm in degrees. And the reason I know it's a no calculator problem is because this is a special right triangle. Okay? So, because I took the square root and because I had to put the plus or minus in here, I'm getting answers in all 4 quadrants. So that's what you guys love to forget on a square root problem. All right, whenever you take the square root of something, we have plus or minus. So if I have 1, 1, root 2, this is a 45, 45, 90 triangle. But I need an answer in all 4 quadrants. So I need a reference angle of 45 here, a reference angle of 45 here, and so on, so on, so on. So my answer in quadrant 1 is obviously just my reference angle. So theta could be equal to 45 degrees, 135 degrees, 225 degrees, or 315. And yes, you need all 4 answers, okay? We're looking for every single possible answer in between 0 and 360. So because we took the square root, we were allowed the positive or the negative version. And that's why we got answers in all 4 quadrants. It looks like something similar is happening here in number 4. I'm going to skip that one and let you guys do that one for homework. Again, something similar in number 5, but I'm going to do it with you. So let's see. So this becomes 8 sine squared theta equals 1. I subtracted 4 from both sides. I'm going to divide both sides by 8. Sine squared theta is equal to 1/8. And now I'm ready to take the square root of both sides. So I get the sine of theta is equal to plus or minus 1 over the square root of 8. Could I simplify the square root of 8 to 2 root 2? Absolutely. You can if you want, but then you need to be careful in your calculator with parentheses and things like that. So I'm going to choose not to simplify it or rationalize, okay? Just simply so I don't make algebraic mistakes in my calculator. So this is not a calculator problem because this is not a special right. So I'm going to come over here and I get second sine. I'm going to do 1 divided by the square root of 8. So if you were doing 2 root 2, you're going to have to use parentheses. So I'm just going to do the square root of 8 so I don't have any calculator issues. Okay. So I get that my reference angle is oh, I'm still in radians. Oh no. So this is clearly, I'm still using my directions from numbers 3 and 4, right? Let's go back and look real quick, make sure we were in degrees. Okay, so I need to switch my calculator back. So let's do that. So mode. So guys, notice how I picked up on that right away. I saw that my answer looked funny because in my brain, I was thinking degrees. But the calculator showed me radians. So this is something that you guys need to be able to pick up on. Especially while you're doing an assessment, because there's no way that Mr. Kirkby and I are going to be reminding you guys to be jumping back and forth between degrees and radians. That's something that you guys need to be able to recognize when you do something like what I just did, and you're like, uh-oh, like this is wrong. And now I can very clearly see that my reference angle here is in degrees. So my reference angle is, I think it was 20.70 degrees. Yes, okay. And I, once again, have plus or minus, so I need answers in all 4 quadrants with a reference angle of 20.70. So it would be, obviously, my quadrant 1 answer for theta is the reference angle. To get the quadrant 2 answer, I would do 180 minus 20.70, and I get 159.30 degrees. And guys, if it says round to the 100th, yeah, you have to put the 0 there. We're rounding to the 100th. So don't just say 159.3, then you're rounding to the 10th. Okay, and then this would be 200. In quadrant 3, I'm going to add it, so it would be 200.70 degrees. And then in quadrant 4, I have to do 360 minus, which would be 339.30 degrees. Okay. Uh-oh, I look at number 6 and it looks different. you guys love to see something like this and then you FOIL it. Don't ever do that. If you get a problem like this, it is a gift. It's a present from us, okay? These are two things that are already factored. So I want you to think back to Algebra 2 when you had something like this, like x minus 2 times x plus 1 equals 0. You were able to say, okay, if these two things multiplied together equal 0, then one of them must equal 0. That's the zero product property. So you would set each one of them equal to 0. And you'd get x equals 2, x equals negative 1. This is a present, okay? It's already factored for you. We're not always going to do that, okay? So we know if two things are being multiplied and then the product is equal to 0, well, one of those two things must have been 0, okay? So either 3 sine theta plus 2 was equal to 0, or 2 sine theta plus 1 is equal to 0. So this is sine theta is equal to negative 2/3. And this is sine theta is equal to negative 1/2. Okay, so you would need a calculator for this one, especially for this part, because that's not a special right. So let's go ahead and do that in the calculator. I have to do second sine, and you guys know I like to just do the positive version so I can get the reference angle. The reference angle is always going to be in quadrant 1. So 41.81 is my reference angle there. So if sine is negative, I need answers in quadrants 3 and 4. So what did I say it was? 41.81. Okay, so then that's going to be 221.81 in quadrant 3. And then over here I would have to do 360 minus 41.81. And I get 318.19 degrees. All right, so that's the answer to the first half of the problem. But I still have to do this side, which we don't necessarily need a calculator for. This is a special right. So once again, sine is negative. And hopefully you guys are recognizing this is a special right. This would be root 3. So my reference angle is 30. And then in quadrant 3, my answer would be 210. And in quadrant 4, my answer would be 330. Okay, so could I have used a calculator there? I could have, because I would have had it. I would have needed it to do this part, so I definitely had access to it. But knowing my special rights, I don't need to do that. All right, so let's take a look. Ooh, so I'm going to skip number 7. Okay, you guys can do that one. That's very similar to number 6. But number 8 is where we start getting a little mean. Yeah, this is one that's not a present, okay? It is not set up in factors for you. These are two separate terms. So we need to factor this before we can do anything, okay? So, you know, in some of these other problems, I'm going to go back to number 1, we just had to do some minor algebra to get sine theta by itself, okay? And then I had to do some square roots to get cosine theta by itself. Number 6 was actually set up very nicely for me. Okay, I didn't really need to do anything except the zero product property and then get sine theta by itself. And now I'm looking at number 8, where I need to do the factoring. Okay, so I look at these two terms and I say, what do they have in common? I want to factor out a GCF. So I factor out sine theta. That's what they have in common, right? And here I would be left with 2 sine theta minus 1. Okay, if I take a sine theta out of each of these terms, I'm left with one of my sine thetas, because this was squared, so there were 2 of them. And then I took out the whole thing here, so I need a placeholder. So now I'm looking at something like from number 7. I have 2 things that are being multiplied, and it's equal to 0. So either sine theta is equal to 0, or 2 sine theta minus 1 is equal to 0. So it was an extra step that I had to do before I could use the zero product property, and it was factoring with the GCF. So where is sine equal to 0? Well, sine is my y coordinate, so I know that happens at one of these special points here. So where is the y coordinate 0? Right there and right there. So we're still in degrees. So here theta is equal to, now I want to just go back and look at my directions, because it's either going to be 0 or 360. I have to see which one was included in the domain. Okay. 0 is included. See how it says less than or equal to? 360 is not included in the domain. So whenever you're on one of those endpoints, just make sure you're including in your answer whatever they're asking for. So my answer here is 0 degrees and 180 degrees. And now I have to do this side, which, okay, so this would be a complete no calculator problem since we didn't need a calculator at all. Sine theta is equal to 1/2. That's going to be in quadrants 1 and 2. My reference angle is 30. Guys, I'll say it right now. If you are someone who doesn't know your special right triangles at this point, you're in trouble and you have to learn them. So 30, 30, so that would be 30 and 150. 30 degrees and 150 degrees. Okay, so yeah, Algebra 2, Algebra 1 factoring does not go away. I'm looking at these next ones. All right, so I'm going to skip number 9 with you guys. Number 9 is another square root one. You can do that by yourselves. Number 10 looks like it's another factoring one. So the only thing that they have in common that I can take out is the cosine of theta. And I'd be left with 3 cosine theta plus 5. So I get cosine theta is equal to 0, or 3 cosine theta plus 5 is equal to 0. So this is cosine theta is equal to -5/3. Over here, cosine's my x, so it takes place right here at 0, 1, and 0, -1. So on this side, my answers are 90 and 270 degrees. And then on this side, uh-oh, I need my calculator. Oh, hold on a second. Right away, I see red flag. I'm thinking this is adjacent over hypotenuse. I was about to put it in my calculator. I was going to bring the calculator up, but I know right away that this is just not possible. Okay, I'm not going to get a solution on this side. So I only have 2 answers to this equation, and the 2 solutions are 90 and 270. You're never going to be in a scenario, guys, where the adjacent side can be longer than the hypotenuse, right? The 5 can't be bigger than the 3. So, I mean, I could not realize that and then go to my calculator here. So if I do second cosine 5/3, it's going to say error, right? So the calculator would tell you that if you did make it that far. But yeah, you can never have, the hypotenuse has to be the largest side. All right, let's see. I think we have 2 more. Okay. I think all right. I was on the fence about doing these. I'll do number 12 with you. And I get secant x plus 2 is equal to 0, and cotangent squared x minus 3 is equal to 0. So I get secant x is equal to -2, and cotangent squared x is equal to 3. Cotangent x, I'm going to square root both sides, is equal to plus or minus the square root of 3. So this would be a no calculator problem. So secant, if I have my ASTC, secant is the reciprocal of cosine. So secant's positive here and positive here, so I'm crossing those out. So I want secant to be -2. So this is going to be -1, and that's 2, right? So it's hypotenuse over adjacent. So this would be √3, so my reference angle is 60. We're still in degrees, so this takes place at 120 degrees and 240 degrees. Oh, that's x, not theta. Okay, and then over here, this is also a special right triangle. So it's plus or minus, so it's going to be all 4 quadrants. So that's √3 over, oh, cotangent, not tangent. So that would be adjacent over opposite. √3, 1, this is 2. So this is a 30, 60, 90 with a reference angle of 30. So x would be equal, we need a reference angle of 30 in all 4 quadrants. That'd be 30, 150, 210, and 330. Guys, I am going to do one more problem with you just because I'm a little upset there was not one more type of example. Do I have a pen here? I do. I just need to write it on a piece of paper first, so you can just fast forward because this is going to take me a second to write. So let's see. Oh, washing machine's done. Do you hear the song my washing machine plays when it's done? All right, let me just make sure I did that correctly. Good. Okay. All right, this is your next problem. 3 tan squared x minus tan x, so you can just put this wherever you want, minus 2 is equal to 0. Okay, so this is another type of factor that you are expected to know and remember from Algebra 2. So you guys probably remember it looking like this. 3x squared minus x minus 2 is equal to 0. And you were all taught different ways how to factor. I think some of you were taught to do this and get the negative 6 and say what factors of negative 6 add up to negative 1, and you'd have negative 3 and 2. I don't really care how you guys want to factor as long as you do it. Okay, so this is no difference except it's not x squared, it's tangent squared, okay? So we can go with that. So since I started it this way, I will do it this way. This is actually not my preferred way of factoring, but since we have these factors already written out, I will do it that way. So I do 3 tan squared x, and I bring in these guys. So I'm going to rewrite negative tan x as minus 3 tan x plus 2 tan x minus 2 is equal to 0. And then we do grouping. Okay, and in the first group, I can take out 3 tan x, and I'm left with tan x minus 1. And in the next group, I can take out a 2, and I'm left with tan x minus 1. And that's the goal of grouping, is that you have matching groups here. So now I can take out tan x minus 1 from each of those terms, and then I would be left with 3 tan x plus 2. And now we're looking at a type of problem from before. So like, remember when I said to you guys it was a gift when the parentheses were given to you? Yeah, it's a gift because you get to skip all of this factoring. So here I have tan x minus 1 is equal to 0, and 3 tan x plus 2 is equal to 0. So this one's an easy one. So tan x is equal to 1. That's a 45, 45, 90. So that takes place at 45 and 225. Okay, so if its tangent's positive, you're in quadrants 1 or 3 with a reference angle of 45. This one I need my calculator for. So tan x is equal to negative 2/3. So let's bring the calculator up. So second tan, and you guys know I just like to see the reference angle. So I'm going to do positive 2/3 and then just figure out what quadrant I need to be in. So that's 33.69. So my reference angle is 33.69. So if tangent's negative, I need to be in quadrants quadrants 2 and 4. So I'm going to do 180 minus 33.69 and 360 minus 33.69. That's going to give me my answers in quadrants 2 and 4. So is this x? This is x. So 180 minus 33.69, that's going to be 146.31. And then in quadrant 4, that's going to be 360 minus 33.69. That's going to be 326.31. Okay. So guys, that's just an extra example I did in there for fun, and you can thank me later because these are definitely going to show up. All right. Hopefully this video wasn't too long. I feel like it was a little lengthy. I hope you enjoyed it. I'll talk to you soon. Bye-bye.